Good morning, students. This is the next topic, that is aryl halides. If we complete this one, we can complete first chapter of organic chemistry. What is our aryl halides? Aryl means arenes. Arenes means benzene rings. If halogens present on benzene rings, that is called aryl halides. For example, if chlorine present on benzene ring, that is called chlorobenzene. If bromine present on benzene, that is called bromobenzene. If iodine present on benzene ring, that is called iodobenzene. If fluorine present on benzene ring, that is called fluorobenzene. So like that we can say aryl halides. In this case, these are IUPAC names, but common names is phenyl chloride, phenyl bromide, phenyl iodide, because benzene ring is said to be phenyl. Benzene ring is said to be phenyl. So that phenyl chloride, phenyl bromide, phenyl iodide, nothing but aryl halides. These are common names, but these are IUPAC names. So the IUPAC name of aryl halides is haloarenes or halobenzenes. Haloarenes, nothing but chlorobenzene, bromobenzene, iodobenzene. So those are what? IUPAC names. But the names which are present in brackets, those are called common names. Now we have to discuss about its preparation and properties, preparation methods. When benzene reacts with chlorine in the presence of anhydrous AlCl3, then we get chlorobenzene. We got already this reaction in class 11 chemistry in benzene topic. Similarly, when benzene reacts with bromine, then we get bromobenzene. Similarly, when benzene reacts with iodine, then we get iodobenzene. Here one important point is there regarding this reaction, that is, during this reaction HI is formed as byproduct, but this HI acts as best reducing agent. That means it readily loses hydrogen atoms to this product. Again, backward reaction takes place. To prevent backward reaction, we have to use oxidizing agents. They are either HNO3 or HiO3, nothing but nitric acid or iodic acid. When you use these reagents, then backward reaction will be prevented. So this is the one of the preparation method for aryl halides. One more reaction, that is Hunts-Dicker reaction. Hunts-Dicker reaction. Yeah, that means in Hunts-Dicker reaction, every time we should take silver ester. Silver ester. COOR is called ester. COOAG is called silver ester. We have to take such type of compound in Hunts-Dicker reaction. When that compound reacts with chlorine in the presence of CCl4, then we get chlorobenzene along with AgCl. So this is also one of the manufacturing method for aryl halides. Next reaction, Sand-Meyers reaction. This is very important reaction. This is one of the named reaction. These named reactions are very important in CBSE level as well as in competitive level. Whichever the reactions, what are the reactions, what type of reactions, these named reactions are very important. You have to learn each and every named reaction. Next, in this reaction, this is called benzene disonium chloride. This is benzene ring. This nitrogen is called azo. Here two nitrogens are present, so that diazo. Positive symbol is there, that is IUM, that is said to be IUM chloride. So this total compound is called benzene disonium chloride. This is one compound. When this compound reacts with cuprous chloride, Cu2Cl2 is said to be cuprous chloride in the presence of HCl. That means these are reagents. Then this total group is replaced by halogen. Then we get chlorobenzene. This is also one of the preparation method of aryl halides. Next, one more reaction, that is, again, when benzene disonium chloride reacts with this time cuprous bromide in the presence of HBr, same phenomenon takes place as in previous reaction. That is what? This total group is replaced by bromine, then we get bromobenzene. So whenever this equation is asked in exam, you can write either of the equation. You no need to write both the equations. Suppose if you get Sand-Meyers reaction in exam, you can write either of the reaction. Next reaction, Gatterman reaction. Gatterman reaction means here also you have to take same reagent as in previous reaction, that is benzene diazoxide chloride, but reagent is different. Here this is copper and HCl. In previous case cuprous chloride and HCl. Here you should take only copper and HCl. Then this reagent replaces this diazonium part by Cl. Then we get chlorobenzene. Here also copper HCl. Copper HCl. Sorry, not HCl, here HBr. Sorry, here HBr. Then we get bromobenzene. In this case we have to take potassium iodide. Then we get iodobenzene. So all these reactions comes in Gatterman reaction. Here you have to observe one point, that is in both the Sandemann's reaction and Gatterman reaction, reactants and products are same but reagents are different. In case of Sandemann's reaction, reagent is cuprous chloride HCl or cuprous bromide HBr, but in this case copper HCl or copper HBr, but in both cases reactants and products are same. Next, one more important point, both are named reactions. Next, so these are the preparation methods which are present in our NCERT textbook regarding preparation methods of aryl halides. Next topic is electron donating groups. We discussed already these points also in class 11 chemistry. The groups which donates electrons are called electron donating groups. For example, alkyl group, R is called alkyl group, alkyl group, ether group. Electron withdrawing groups means the groups which withdraws electrons are called electron withdrawing group. For example, NO2 nitro group, halogen groups, carboxylic acid group, aldehyde group, ketone group, cyanide group. All these are electron withdrawing groups because when they are present in an organic compound, they used to withdraw electrons from that compound. Here one exception point is there, that is when halogen, chlorine, fluorine, bromine, iodine present on benzene ring, they act as electron donating group. That means they donate its electrons to benzene ring. See, when electron donating groups present on benzene ring, what happens? Electron donor, I told you just now, these are halogens. When these are present on benzene ring, it donates electrons to benzene ring. Then what happens? Then negative charge appears at ortho and para positions. We discussed these points also in class 11 chemistry. You can see those points once again. From these points we can say one important point, that is wherever negative charge is present, their electrophile will come. Wherever negative charge is present, their electrophile will come and attack. That means when electron donating groups, that means when the electron, this is an important point, when electron donating group present on benzene ring, then electrophilic substitution attack at ortho and para positions. Electrophilic substitution, this is very important point. Whenever electron donating groups present on benzene ring, then electrophilic substitution takes place at ortho and para position. Because why electrophilic substitution takes place? Because negative charge is present at ortho and para. Automatically electrophile will attack at those positions. Next point, reactivity of alkyl halides is very less towards nucleophilic substitution reaction than alkyl halides due to partial double bond character between carbon and halogen in aryl halides. This is very important point in aryl halides. What is the meaning of this point? Actually, in case of alkyl halides, nucleophilic substitution reactions takes place. Compared to alkyl halides, in aryl halides, the reactivity of nucleophilic substitution is very less because partial double bond character is present between carbon and halogen. See, for example, I will show the example, then you will get clear idea. See, CH3Cl, this is alkyl halide, nothing but methyl chloride. When this compound reacts with KCN, then we get CH3CN plus KCl. We know that very well. What is happening in this reaction? Nucleophilic substitution reaction takes place. How can we say that? In this case, Chlorine is nucleophile. How can we say that? CH3 plus Cl minus. Here K plus Cn minus. This nucleophile replaces this nucleophile in this reaction, so that this will be formed. That means which mechanism takes place? Nucleophilic substitution reaction takes place. So from this what we can say that in alkyl halides most of the reactions are nucleophilic substitution. Not all reactions. Most of the reactions are nucleophilic substitution reactions. So what is the point here? Compared to alkyl halides, the nucleophilic substitution reaction reactivity is somehow less in case of aryl halides. Because of what? Partial double bond character between carbon and halogen. How can we say that? If you see these resonance structures, you can observe that point. See, these are aryl halides. In these resonance structures, you can observe one point, that is what? Between carbon and halogen, double bond character is present. That means when halogen present on benzene ring, between halogen and carbon, double bond is present, but that is not visible. But we have to feel that double bond is present between carbon and halogen. Because of presence of double bond, these bonds strength will be somehow more between carbon and halogen compared to carbon and halogen in alkyl halides. I repeat that point once again. Because of partial double bond character, the bond strength is somehow more between carbon and halogen in case of aryl halides compared to carbon and halogen in case of alkyl halides. So automatically this bond strength will be more and it is very difficult to break. So that nucleophilic substitution reactions takes place very difficulty in case of aryl halides. Next, one more point. When electron withdrawing group present on benzene ring, electron withdrawing group, then electrophilic substitution reactions takes place in meta portion only. See, this is electron withdrawing group. When this group present on benzene ring, then positive charges appears at ortho and portion, ortho and meta portions. This is ortho portion. This is para portion. This is ortho portion. But this is meta portion. To this group, these adjacent portions is said to be ortho, and these portions is said to be meta, and this opposite portion is said to be para. I discussed all these points already in class 11 chemistry. So what is the point here? When electron withdrawing group present on benzene ring, then positive charge appears at ortho and para portions. Then electrophile cannot attack those portions. It can attack at a meta position. This is very, very important. Due to presence of positive charge at ortho and para portions, the incoming electrophile cannot attack at ortho and para portions. It can attack at meta position only. So what is the point here? When electron donating groups present on benzene ring, the incoming electrophile will attack at ortho and para. But when electron withdrawing group present on benzene ring, then the incoming electrophile will attack at meta position because of these resonance structures. Next topic is chemical properties of aryl halides. Chemical properties. Just now we discussed already about nucleophilic substitution in case of aryl halides. That is somehow less. Somehow less means reactivity is somehow less in case of aryl halides due to partial double bond character between carbon and halogen. If electron withdrawing group present on benzene ring, if electron withdrawing group present on benzene ring, then nucleophilic substitution reaction takes place easily in case of aryl halides. This is very, very important point. If suppose electron withdrawing group present on benzene ring, what we have discussed here, positive charge present at ortho and para portions. If that group increases, if that electron withdrawing group increases, what happens? Then more amount of positive charge appears at ortho and para portions. Then to that portions nucleophile can come. That means nucleophile substitution reactions takes place easily. If automatically electron withdrawing groups increases, then rate of reaction also increases. You have to understand these 3 points very carefully. What this point says about what? If electron withdrawing group present on benzene ring, then electrophile can attack at a meta position, because electrophile cannot attack at earth and para position. Electrophile means positive charge, so positive cannot, to positive position can another electrophile cannot attack. So that incoming electrophile can attack at the meta position, but nucleophilics can attack at earth and para. Nucleophile means what? Negative charge. So that negative charge immediately comes at a positive charge. So what is the point here? When electron withdrawing groups present on benzene ring, then nucleophilic substitution takes place readily, easily. If electron withdrawing groups increases, then rate of reaction also increases. For example, see, this is chlorobenzene. When this chlorobenzene reacts with the aqueous NaOH in the presence of this temperature, 623 Kelvin temperature, what happens? This OH directly replaces chlorine. Then we get phenol. Phenol means if OH present on benzene, that is said to be phenol. Now I take one more reaction. If you take this compound means para-nitrochlorobenzene. Reacts with the same reagent, aqueous NaOH, but here temperature is 623, here temperature is 473 Kelvin. That means compared to here temperature is somehow less. Even though temperature is less, reaction takes place very easily in this case, because here electron withdrawing group is present. If electron withdrawing groups increases, rate of reaction increases. So immediately this chlorine is replaced by OH of NaOH. If two electron withdrawing groups are present in chlorobenzene, here temperature is 370 Kelvin. That means compared to here temperature is less, but rate of reaction increases, because what? Number of electron withdrawing groups increases. So if number of electron withdrawing groups increases, nucleophilic substitution also increases in case of aryl halides. Here 3 electron withdrawing groups. Here temperature, just warm means light temperature. That means from here to here temperature decreases. From if you observe the temperature in each reaction, here temperature is more, but here warm is light temperature. That means here temperature is very less compared to previous 3 reactions, but rate of reaction increases, because here 3 electron withdrawing groups are present. So automatically rate of reaction will be faster. Which rate of reaction? Which reaction? Nucleophilic substitution reaction. Then 2,4,6 trinitrophenol will be formed. So this is all about nucleophilic substitution reactions in aryl halides.